Hello everyone, so I will be solving another LeetCode problem which is merge intervals. Let's read the problem. Given an array of intervals where interval I is start I, end I, so intervals is essentially a list and the ith element contains start and end of a interval. Then we are asked to merge all the overlapping intervals and return an array of a non-overlapping interval that cover all the intervals in the input. Okay, let's take an example so that we understand it correctly. So this is intervals array, which contains, this is start point, this is end point, and similarly it's for all the elements in the interval list. So it has 1, 3, 2, 6, 8, 10, 15, 18. So let's take a look. It says we need to merge all the overlapping intervals. So if we actually look at 1, 3 and the second element is 2, 6, actually 2 overlaps the timing over here, right? The start time in the first element is 1 and the end time is 3, and 2 essentially lies between 1 and 3, so there is essentially an overlap, and I think that we need to merge it into 1, 6. And then in 1, 6, so in start interval 1 and interval 6, and the next element is 8, 10. So 8 does not really lie between 1 and 6, so I think we won't be merging. And then similarly I think for 15, 18, since 15 is not between 8 and 10, we won't be merging it, so it should be 1, 6, 8, 10, 15, 18. And I think, yeah, that's essentially the output. The explanation is same. 1 and 3 and 2 and 6 are overlapping, right? So we need to find elements. So if one, so essentially if a element lies between the start and the end time of previous element, then we'll know that there is some overlapping, right? Because we can clearly see 1, 3 and 2 and 6, there is a overlap, so we need to merge. And what essentially we need to do, if you actually observe over here, what we are doing, we are just taking the start of the previous element and end of the last element. But it won't be necessarily the same case, right? What if we are given 1, 7, right? So if we are given 1, 7, 2, 6, then it's going to be 1, 7, because 7 comes before 7 comes after 6, right? So we need to take the bigger of whichever, either the ending of the first element or ending timing of the last element. So it should essentially be max of these two values, right? Let's take a look at the second example. In 1, 4, 4, 5, okay, so there is a overlap, right? Because 4 exist in both, so end time of first element and start time of second element, they are essentially same, so we can actually merge it in, right? So that's that. So that's why we will see 1, 5. So it's pretty clear, right? So if you actually look at the example, it's much more clear that if we see overlap between two elements, we are just going to take the minimum of the first element and the maximum of the second element. But also, if you actually take a look at first and the second example, these are all in sorted orders. What I mean by sorted order is that if you look at the first element of each, or the start times of each list, they are in ascending order. So 1 is less than 2, 2 is less than 8, 8 is less than 15, but it's not actually given in our problem statement, right? So that means that we can't really make an assumption, although in both of these cases it's in ascending order. Start time of the first element is less than the start time of the second element. So although this is sorted, but we need to make sure that we are sorting, because it does not really give anywhere in the problem statement that it will always be sorted. So one thing which we are going to do is we are going to sort the given intervals according to the starting time, right? So once we have that, we know that it's going to grow in. So the first element would definitely have the less or equals to start time of the second element, and so on and so forth. So this is going to help us to know that if we are looking between first and second element, or second or third element, the previous element's starting time would definitely be less than or equal to the starting time of the second element. So that's what's going to help us in at least making this problem simpler, right? So let's do one thing. Let's just sort the given intervals first. So we need to pass start and the end of interval. Oops, I made a mistake. should be interval dot end. Also, it should be intervals because that's what's given in our parameter. So once we sort them, what we need to do is, we don't have to worry about the start of the element, right? If we are comparing, for example, let's just make it simpler, right? Let's just take two lists at a time. So start time, we know since we have already sorted, and when we sort like this, it make an assumption that we are just sorting. Since it's a list of list, it's just gonna sort according to the first element. So it's gonna be sorted according to starting of all the intervals given to us. So we know that for sure either it's gonna be less than or equal to. So we don't really have to care about the start time. But now if there is an overlap, we need to find the maximum between the end times of both the intervals, right? But if it's not, for example, in this case, so 5, 10, 15, 18, since 15 does not lie between 8 and 5, we just directly, we do not do anything, we just keep them intact, right? So now we know that we just need to make change when the starting time of the next element lies between the interval of previous element. So that's the only time we need to change it. Otherwise we are just gonna create or just have the intervals same as it should be. So for this case, we will be using an extra space, right? The reason I'll also tell the reason why I'm using extra space at the end of the video, so that you better understand. So let's do one thing. Let's just say we are gonna be iterating in intervals, and then we are gonna check if. So now what we are gonna do, since answer is we are just gonna return answer. So let's just say return answer at the end, and we'll be constructing this answer from the given intervals. So in the case when there isn't any overlap, just amend to it, right? But there is another condition which you need to take care. If there is no elements, or the list is empty, so the returning list, which is answer, if answer is empty, then also we need to push, right? So we will be writing two conditions, either answer empty, if answer is empty, or if the intervals start time is greater than the last end time of previous element, right? So what we're going to do is either answer dot empty, either if it's empty then also push. So what we're going to do is answer dot push back interval. So we are just going to push the interval. So either it should be, if it's completely empty, then just go ahead and push, or if the start time of the interval, so let's just say interval start time is denoted by 0 because that's the first element. If that's greater than the previous element, which is already going to be in the list, right? So previous element over here is going to be answer dot back, because there is an assumption that answer won't be empty, right? Because if it's empty, we are directly pushing back, right? So if it's not, then only this statement is going to execute, otherwise it's automatically going to push. So if answer dot back dot first element, so first element or the first indices actually denote the end time. So if end time is less than, so in this case 10 is less than 15, then also we need to push back in, right? So that's what's going to happen. And now this is the major logic. What if the start time of the interval is which lies between the previous intervals end time? In that case, we need to actually take max of the end of either first interval and second interval. So we need to check both, right? So over here I'm gonna just say answer dot back, because we have already appended 1 3, right? So now we are gonna say, hey, if the whichever is maximum, either the interval over here, so if 6, whichever is the end time is greater, just push it back in. So we are just gonna say, or not push it back in, we actually gonna amend it, right? Because that's what we are gonna do over here, is we are gonna say, hey, take the max of either the already existing, so already existing is 1 3, just take the max of either n time of answer or the new interval which we have encountered. So it's going to be max of answer dot back or intervals 0, right? Interval 0 essentially denotes this, or actually it should be interval of 1, right? Because it should be n time. So either get the answers n time if it's greater, if not then look for the intervals n time, and that's why it's gonna be like, oh, 6 is greater than 3, so that's why this whole interval is gonna merge it into 1 and 6, and that's what we are doing. We are saying, hey, just change the answers n time, or whichever last answer is, just change its n time to maximum of either already existing n time or just intervals, new intervals n time. So that's gonna give us the max of both the element, and then this is gonna be our answer. Let's run it. Okay, it passes all the cases. Let's submit it. Alrighty, it got accepted. So let me explain it again. It might be a little bit confusing at first if you're looking at this question for the first time, but if you actually look, the code isn't that complicated, or rather you need to think a little bit about this creating a new answers vector, right? The reason I'm creating new answers vector is because in this case, if I try to just change the vector, I have to essentially change this 1 3 to 1 6, and then I have to delete 2 6. And if you know, deletion or erasing any element at a particular index is O of n, taking n is the number of the elements. So in worst case, if we are looking at the end element, you have to iterate every single time. That's not time complexity wise, it's not really a good solution. That's why I just took a new container, so that as we go, I'm gonna build this container. I'm gonna put the element, so when it's a empty, if we don't have any element, we just want to directly push it back in, right? Because there isn't anything to compare it with. But once we have it, so if I do a dry run for the first time, 1 3 is gonna get appended in answer, and the next time we are gonna check, hey, is answer interval 0, so in this case 2, if 2 is greater than answer back 1, answer back 1 is essentially give me the previous elements in time. So if it's greater, then push back, but in this case it's not, right? So it will come into this else condition, and then it will say, hey, look for the maximum between the previous elements end time or the new intervals end time. So it's going to compare between 3 and 6, and it's going to say, okay, 6 is greater than 3. So it's essentially it's going to change the answers back end element. So it's not going to create a new vector, it's just gonna erase this 3 and make it 6, so it's gonna be 1 6, right? That's the most important part. I'm not pushing back any new element into it. If you carefully look, I'm changing or I'm amending that previous so answer back means the last element which I pushed in answer, then I'm just changing the end time of it. So I'm just be careful while reading this particular line. I'm not pushing a new element. All I'm doing is just give me the maximum of the interval which I'm encountering with the already existing answer. So it's gonna just compare between 3 and 6, and it's gonna say, okay, 6 is greater, so I'm just gonna erase this 3 and gonna make it 6. And remember, I'm not pushing back, I'm just leaving this. I'm just gonna change into the answer array, so it's gonna be 1 6, and we just don't continue, we go on to the next one. And the same thing happened with 8 10, right? And again it's gonna come into this for loop, and it's gonna say, hey, is 8 greater than 3? And it is, right? So it's just gonna push it back, and same thing will happen over here. So it's gonna compare 15 with the end time of 10. So is 15 greater than 10? Yes, it is. So it's gonna push it back. So this is the logic for just pushing it back in if we don't find any overlap. If there is an overlap, then we are gonna do it. So let me just also comment it down so that it's better understood to you guys. When there is a overlap, oh sorry, actually it's the other way around. So it's actually this condition of this logic is for overlap. This is if there is no overlap. So this is for a overlap, this logic, and this is for no overlap. I hope this makes sense now. The reason I also explained the reason why I'm using answer and not actually amending this interval, because I have to erase, and erasing in a list is not a constant time operation. It's actually gonna iterate and find the element and then gonna delete, and that's why I'm just creating a new vector so that we don't have to again go back. And yeah, so let me also discuss the time and space complexity. So this is sorting, so sorting the time complexity. So I'm gonna just say TC. Let me just write it down. Time complexity for sorting is gonna be, since I'm already using, so it's the already existing sorting function, it's gonna be NlogN, given n is the number of elements, and then I'm just over here I'm creating a new vector, so it's gonna be, the space complexity is gonna be O of n, right? Big O of n, given the n is the number of elements over here. And yeah, this is the operation I'm performing is constant time. We are just evaluating and then pushing back and just making change to that. So that's your time complexity and space complexity. So this time complexity is just for sorting, and this is gonna be O of n, but n plus big O of n plus n log n is n log n, because n does not, it doesn't really matter because we already have n log n as, that's a bigger value than n, so it's gonna resolve to n log n. So that's the time complexity, that's the space complexity, and this is the solution for merge interval. Do let me know if you guys do not understand any part of it. I can explain it again, but do let me know what you think about it in the comment section below. And yeah, that's all for this question. I will see you in the next one.